Here we have another interesting problem where I got to do some thinking and use what I may know about some trigonometry, maybe even some trigonometry of special angles. But let's see, we got a clock here. Let's read this thing. A 3-inch long minute hand on a clock shows the time at 45 minutes past the hour. What is the new position of the end of the minute hand relative to the pivot point at 10 minutes past an hour? Of course, my clock as it shows is 10 minutes past the hour. Well, let's think about what we know here. One, we know that this minute hand is 3 inches. And my pivot point, of course, is right here. This is where everything pivots around, so that's what we're talking about. What is the position? So I want to know what this coordinate would be, x and y coordinate maybe right at the end of the minute hand. That's really what I'm trying to figure out. Now, I might think about this as a reference angle, coming back to the nearest x-axis. Of course, that's not a straight line, but see if I can make it a bit straighter. Not much. Anyway, so thinking about what is my reference angle. Now, we know that there's 360 degrees in a circle, and there's 12 units on this clock. So how many degrees is it between each unit? In other words, from 12 to 1, 1 to 2, 2 to 3, and 2 to 3 is really what I'm interested in. How many degrees is that? Well, if there's 360 degrees and there's 12 units on the clock, I could take 360 and divide it by 12 and I get 30. So that means that this reference angle here between 2 and 3, because that's where my x-axis would lie going towards that 3, is 30 degrees. Now, I want to think about it. That's 30 degrees is a special angle. What's the cosine and sine at 30 degrees? Well, you may remember, and if not, you need to think about it and begin to memorize it. But that means that the cosine is going to be the square root of 3 over 2, and the sine is going to be 1/2. All right, let's jump over here where I got a little bit more room to work, and let's think about this. So if my cosine is the square root of 3 over 2, this is on a unit circle now, and my sine is 1/2, but that's assuming that the radius is 1. But we've already determined that this minute hand is 3 inches long, so it's 3. And there's a couple of ways that we could solve that. Probably the easiest way, I'm going to do it both algebraically and that set up a proportion. But I could really just simply take 3 times the square root of 3 over 2 and 1/2 times 3. Let's see, that'd be 3 square root of 3 over 2 and 3/2. Of course, we're in inches. But let's set it up as a proportion and see if it proves out that way. So we could say, okay, well, if the cosine, which is equal to the x-coordinate, and if the cosine is the square root of 3 over 2 when the radius is 1, well, that would equal x times 3 with a radius of 3, and we end up at the same point, 3 square root of 3 over 2. What about the sine? Well, the sine's equal to y, the y coordinate, and so I'd have 1 over 2 equals y over this radius, which is not 1 but 3, and y equals 3/2. All right, well, let's see. And we're doing this in the distance, it's in inches, so let's go ahead and get this approximately. So if I go 3 times the square root of 3 divided by 2 2.59. I could then say that the minute hand, right here at this point, the minute hand is, and here's my pivot point again, my minute hand is approximately 2.6 inches to the right of that pivot point, and it is 3/2 is 1.5, and 1.5 inches above the pivot point. That's pretty cool. All right. There we go, finding the coordinates, given a radius and an angle. We actually used the reference angle. It was a special angle, so I was able to use my cosine and sine, my x and y coordinate, from that special angle, and I just had to count for the increased radius on the unit circle was 1, but the minute hand on this clock was 3, and with a little bit of thinking, I come up with the correct answer. You want to have fun? Win. You want to win? Or